All right, ExcelChem kids. Hopefully you've now received this piece of paper right here. This is the start of learning about chemical reactions, and really what we want to do is start breaking apart what we're looking at here, because last unit you learned how to write formulas and then how to name formulas, and you could see this is nothing but formulas on the sheet right here. So we're going to break it down. I know, I do that a lot, and the kids think I look stupid. Keep going. All right, so yeah, we're gonna break it down and look at all the different parts of this. So if we look at number one, so just look at the worksheet right now. This first compound starts with an H. So what kind of compound is it? Yeah, I'm gonna pause like this, and if you want, while you're watching the video, you can just like yell out answers and entertain yourselves. So, did anybody yell out acid? Fan-freaking-tastic! This is an acid. Now this part of the compound you should recognize is the acetate ion, and notice how it ends in ATE. So the naming of this one will be, go ahead, yell it out, pausing, acetic acid. Really, acetic acid is nothing more than vinegar. Okay, vinegar is just our common name. Now, if you look at this one, you should recognize we have a metal, and then we have a negative charged ion right here. And hopefully you can look at those names. The Na name you guys should be able to recognize pretty quickly. So I'm pausing for you guys to yell out sodium. Now you got those ion sheets, because hopefully you started looking at those ion sheets and are looking for this HCO3 right here. I gotta give them some time to look for this. You should look in the first column, I think. Yes. It's bicarbonate. That's really just another name for baking soda. And if you look right here in front, I have baking soda and vinegar, and I'll be doing a demonstration for you guys with these things. But before I actually do the demonstration, I want us to take a look at the products that we're going to have. And that's the other thing I need you guys to see is the terminology we call this. Everything on this side of the equation, I already called the products. All right? So everything on this side of the equation also has a name, and that name is called reactants. This arrow even has a name. Yeah, it's not called arrow. It's called yields. So our reactants yield our products. So our reactants are acetic acid and sodium bicarbonate. And the thing that we're going to yield is sodium. And that's still the acetate ion. And yeah, I know you guys know that's water. But if you think about the actual name that we learned about before, dihydrogen, let's spell it right, dihydrogen monoxide. And our last one here is carbon dioxide. Okay, so we're going to actually test for this. If you look at my beaker, I'm going to go ahead and put some vinegar in there, which is my acetic acid. I'm also going to sprinkle in some baking soda. Oh, good, there's a spoon in there. And if we really are making carbon dioxide, we should be making a particular state of matter. Can you see that particular state that we're forming? That state are those bubbles. So I want to test those bubbles. Because whenever flame goes near carbon dioxide, a flame goes out. So you can see all I have to do is hover near the opening where this carbon dioxide is being formed. And every time I do that, I have evidence that the carbon dioxide is what was being produced. All right? So we never saw that carbon dioxide So I want to analyze our formula here again. You guys should notice this teeny tiny little G that's right there. What that does is tells us what state of matter that carbon dioxide is, and G means gas. If you go back and look at this beaker here, we still have liquid in it, right? It stopped bubbling. So that liquid, let's go back to our sheet again, is this teeny tiny little thing right here, liquid, and that's the dihydrogen monoxide. All right, and then there's one more thing that we produced, which we're not going to be able to see actually in here, because the solid that we see at the bottom is still baking soda that didn't react. Okay, so we're not looking at the solid that's in there. The other thing we cannot see, and that's what this little AQ means. The AQ is the word for aqueous, which means that this material here is dissolved in water. And when something's dissolved in water, we can't see it. So we have a gas that's produced, a liquid that's produced, and a material that dissolves in water. And we got that all from, see that S that's there? The solid baking soda or sodium bicarbonate. And then the vinegar was not pure acetic acid. If it was, oh my gosh, the smell would be atrocious and I would not be able to sit here next to this thing. So AQ means it was also aqueous and that we had just some acetic acid in there with water. Specifically, if you look at these bottles, it's only 5% acetic acid. The rest of it's all water. Okay, so that's our first formula that we're looking at. So now we're going to look at our second one. Okay, so coming back to me, I guess. So hi. So we're going to analyze the sheet some more because that's really what we have to look at. Okay, notice sheet. There we go. Notice I named for you the first material here, and I called it hydrogen peroxide. And then there's a little L. What does that mean? Pausing. Yeah. Hopefully somebody yelled out liquid. But this is a new thing that we have not seen before, right? In this first equation, there was nothing written over the arrow. And when something is written over the arrow like this, what that means is that this material is a catalyst. And those of you who are in biology or were in biology last year, you guys know that a catalyst is something that speeds a reaction up. So this hydrogen peroxide that we have here is a stronger hydrogen peroxide than what you guys would find in the grocery store. Yeah, I put it in this bottle here that says 30%. The one you buy at the grocery store is only 3%. So this is the stuff that can burn your skin. So this hydrogen peroxide, all hydrogen peroxides actually have an expiration date somewhere on the bottles. And I'm kind of looking around for this one's. Yeah, I'm not finding it, but they do. Trust me, they're supposed to have an expiration date on here because after a period of time, these things actually go bad because hydrogen peroxide is always undergoing this reaction. Hydrogen peroxide is always doing this, and then this just makes the reaction speed up. So what is hydrogen peroxide always making? Yeah, it's making this liquid here called dihydrogen monoxide. And then we also remember that there were 7 elements that always occur diatomic when they're by themselves. This is one of them. So it's just oxygen. And you can see that with this little G here, it's actually oxygen gas. All right, so hydrogen peroxide is constantly doing this. We're just gonna make it go faster. And we're gonna do that by using this material here, which is our catalyst, which is the manganese 4 oxide. They also give it a name, manganese dioxide. I don't know why they name it 2 different ways. I'm sorry. When you look at the formula, you should be naming it manganese 4 oxide based upon the method that I showed you guys. All right. So I need to just put a little bit hydrogen peroxide in. I also need to get my match ready. Because if we're making oxygen gas, I want to be able to test that oxygen gas. All right, so. I don't know if you guys can see, but when I first put it in there, it started glowing a little bit brighter than what it originally was doing. And the oxygen should have, oh, there, see, it just relit again. And there it is relighting again. Okay, now that is what I wanted to show you guys with this reaction here, is that we actually produce oxygen gas, and we're able to test that. Okay, so our third equation, oh, we probably should still look at the paper a little bit more. This is copper. What state of matter is it? And what kind of a compound is this one? Remember, it's starting with an H. All right, it's an acid. And then when we look at the thing that the H is attached to, this thing is called nitrate. 8 means it would be nitric acid. So we're going to have some nitric acid. And although this is aqueous, I'm actually using concentrated stuff. So I'm using a liquid. I'm not even diluting my stuff. Yeah, it's pretty strong. Anyway, I'm going to be making these products here. All right, so let's name them. This one has nitrogen being the first element. Look, see, the hydrogen peroxide burned my fingers. That was that 30% stuff. My fingers are starting to feel burning. All right, this is nitrogen dioxide. Okay, this one starts with a metal, so this is one of our ionic compounds. Copper. And are you guys remembering that copper has multiple charges? So this time we need to use a Roman numeral. And the Roman numeral is dependent upon what our negative thing is. Our negative thing here is nitrate. That nitrate has a -1 charge, and there's 2 of them. So that means our copper is going to have to be a +2 charge. And then, of course, we have our dihydrogen monoxide. Now, I cannot test for this particular product because this stuff is actually poisonous. And you'll see it. So come with me. So here's our nitric acid that we're using, concentrated nitric acid. And then you come over here. I already put it in the fume hood. And we put it in the fume hood because it is poisonous. And then you can see this is just copper metal. And I put it in there. Immediately you can see the change happening. Okay, that green color is your copper nitrate that's forming. It will eventually turn more blue. And now you should see, hopefully with my hand behind here, can you see the color of the gas? It's kind of brownish yellow. Can you see it on the camera? Okay, so that's the poisonous gas that we're jettisoning out of here. Okay, and then that gas is making the bubbles. Right? So you can see the bubbles all in here. And the gas is coming out. So that's our next demonstration. Pretty cool? How much time are we on with this video?
13:20.
Okay, yeah. All right, next. Last one. We're going to skip. We're going to skip this. All I'm not going to do is a demonstration. All I want to do is show you guys this triangle. It means that we have to heat it. Okay? So I'm not going to do that demonstration because I'm running on time and we're almost close to 15 minutes. So we're going to do the methane one. And methane you can see with, remember this is diatomic and it's by itself. So this is just oxygen. And because it's a G, it's oxygen gas. And we're going to be able to make, yep, carbon dioxide. And with the G after it, that's going to be a gas as well. And then we have H here, which is dihydrogen monoxide. Okay, I'm not spelling that right. There we go. And then you see the G there, that's also a gas. All right, so while you're filming, I'm also going to need you to hold something for me. So come on over this way. So keep filming and just hold on to this, and I'll grab it from you. So, sorry, I needed a match to get this lit. And I'll take this from you when I need it, okay? So we're gonna make methane bubbles. I'm gonna make them right here using the Bunsen burner gas that we use. And then I'm going to add a flame to it. So you don't wanna bring the flame next to it at all. You wanna keep the flame away, put the camera on me maybe. And I'll grab that when I need it. Okay. All right. Break. Ah! Okay, I gotta do that again. Trust me, I practice this, right, Alex? I practice
3 times.
3 times. I got the bubbles to work out of 4 tries, right? Or was it 5 tries?
Something like that.
Okay. Did you follow it? Did you get it all?
We're gonna need to do it another time.
Ah.
One more time.
Okay.
Now that I know that what I'm taping.
Okay. So the kids missed it, huh?
A little bit.
It was pretty cool. All right. Oh! This is frustrating when the bubble pops. All right. Oh!
Do we want to pause this and maybe edit?
I don't know how to edit my videos. I just know how to put them on
Just
YouTube.
keep going.
But then the kids can see how frustrated I am and that I'm totally dedicated to making this work. All right, come on, break free. Cool, you got it?
Nailed it.
All right. All right, so I can do more of that when I come back because I'll keep that little bucket there available and maybe I'll make some more of that because one of the things I like to do too is just bubble lots of bubbles in like this. And then students can scoop up the bubbles in their hands and I'll light them on fire and then you can hold on to fire. And then you can pretend like you're a firebender or something like that. See, because when you hold on to all those bubbles like that. Oh, you want to do that? Okay, I'm going to move your shirt farther away from. Okay. Normally they take bigger handfuls. Did you like it?
That was kind of fun.
Yeah. Okay. So when I come back, we'll do more of that. All right. So yay. Hopefully you guys learned something about the symbols. Oh, and come back to this worksheet here. What you should be doing now are the questions that are below here because everything here should have been discussed with me when I went through all of this up above. All right? All right. Hope you guys are missing me. Bye.